Seaborn is a statistical plotting library in Python. It's built on top of matplotlib, which means when you run a Seaborn command, it runs a set of matplotlib commands under the hood. It's built with beautiful default styles for the graph, which makes it easier to read and comprehend. Seaborn is designed to work very well with pandas data frame objects, and therefore it's the go-to library for plotting data in Python. To install the Seaborn package, you would need to use the commands conda install Seaborn if you are using the Anaconda prompt, or otherwise pip install Seaborn if you are using the command prompt. So Seaborn can be used for analyzing different types of data by using different types of plots for numerical data, for categorical data, and even for data in matrix format. So let's start by importing our libraries and some data to work with. So here we will import numpy snp, import pandas spd, import matplotlib.pyplot splt, import seaborn as sns, and we will run a one line code matplotlib space inline. So this last line %matplotlib space inline, this will help to see the visualizations in the Jupyter notebook. Next, we will upload the dataset. So Seaborn comes preloaded with some datasets which we can use for practice purposes. So one of such datasets is called tips. To load the datasets, we can run the command sns.load dataset and just pass in the tips. So we can check the doc string here. It says load an example dataset from online repository. So this function provides quick access to a small number of example datasets. So we can use it for our practice as well. Let's run this. It will load the dataset. So let's check the head of the dataset. So this is our dataset. So it looks like it's from a restaurant. We have the total bill and we have tip data, and then we have some other categorical data. Now let's check the info. So in total it has 244 entries, range index going from 0 to 243, and 7 columns. Total bill, tip, sex, smoker, day, time and size. There are no null values here, and as we can see, the first two columns, total bill and tip, are float data. Then the next four are categorical data, and the last column seems to be integer data. So now that we have our data, let's move on to the distribution plots. So these plots allow us to visualize the distribution of a dataset primarily for the numerical column. So distribution plots are for the numerical data, which will be for floating data and integer data, and this allows us to visualize, if you can consider all of these columns as variables. So for this column total bill, let's say we see some of the bill here, but we want to know the distribution of this column, that where does the most of the bills lie. If you go through the data one by one, it will be very difficult, but plotting it by visualizing it, we can easily look at that plot and analyze where does the most of the data lie. So we have different kinds of distribution plots. We have histplot, which is basically a histogram. This is for univariate data. Then we have jointplot, which is for two different variables, so kind of x versus y. Then we have pairplot, which is for bivariate data for all the pairs of numerical columns in a data frame. We'll see that. Then we have rugplot and we have kdeplot. These are again for univariate data. We'll see that once we get there. So first we have histogram, which shows the distribution of a univariate data. So to plot this, let's say for this data set, we want to understand the distribution of this total bill. So sns.histplot, as you begin typing, press tab and we can check the doc string here. So we need a data, then we need either x or y. Because this is univariate data, we need to pass in only one of x and y. If you pass in x, the graph will be vertical. If you pass in y, the graph itself will be horizontal with base on the y-axis. So let's plot this total bill. Let's run this, and see, this has plotted a histogram for that entire column. So as you can see here, on the y-axis we have count, and on the x-axis we have this total bill data. So if you look at the distribution, most of the bills are between $10 and $20, and as we go higher, the number of bills gets lower and lower. And that is intuitive, right? There would be very few people who would be spending more than $30 for a lunch or for dinner. Of course, there's a variable for number of people as well, which is the size of the group or size of the party. We will get to that later. But for now, if you want to look at the distribution of the total bill, most of it is between 10 and 20, with very little data before that and after that. Now let's check out some other parameters here. We have a bin parameter, which is given auto by default. So let's say you want to divide the entire distribution into 20 bins or 10 bins. So let's run that. Let's go for 10 bins first. We want lesser number of bins, or if you want to increase the bins count as well. So it will give you very minute distribution, but not all of the bins will have data here. So it really depends on the kind of data you have. And there's another parameter. If you take a look, we have this KDE, which is given false by default. So if you want to plot the kdeplot, we'll come to the kdeplot later. But if you want to plot the kdeplot on top of the histogram itself, you can return true for this, and this will plot a kdeplot. Kdeplot is similar to bell-shaped curve. KD is short for kernel density estimation, and it will give you a nice distribution of the data here. And we can also use the hue parameter here, and let's pass in this X column for this. So right now the data selected is only for that one column, so we need to select the entire data frame here. So data will be tips, and then our X would be this total bill columns. So now we can select this, and as you see here, we will have two different histograms. One is in blue color, which is for male, and then we have this in orange color, which is for females. And we have the overlap here as well. If you remove the KDE part, KDE parameter, you can see it clearly here. Let's remove this. Now this is the simplest form of a histogram. It is easier to read, and you can easily see the distribution of a univariate data here. Next, we will move to joint plot. Now, rather than looking at the distribution of one column, let's say you want to understand the relationship between two different columns. For example, for this data set, we want to know what is the relationship of this tip with the total bill column, because intuitively you think that people who have a higher bill will give higher tip amount, right? So we want to visualize that. So to compare the two data together, we have something called joint plot, which is used for bivariate data, that is to compare two variables or two numerical columns from a data frame. It will plot histogram for both data separately and will show x versus y comparison as well using kind parameters. So let's plot this quickly. We'll pass in our data, which is tips. Then we'll pass in the column which we want on the x-axis. So let's say on the x-axis we want total bill column, and then on the y-axis we want the tips column. So let's plot this. Okay, so this column name is tip, not tips. So here, as you can see in the joint plot, in the middle we have this x versus y data, that is total bill versus tip, and this by default has scatter plots. And then for both data set, for total bill it will plot a histogram here, so we can look at the distribution of that data. And then we have a histogram for tip as well, we can look at the distribution of that data as well. Let's first talk about the histograms. As you can see, most of the bills were between $10 and $20, and then the count of the bills went lower as we moved up in the dollar amount. Similarly, for the tip, most of the tips were between $2 and $4, and there's very little tip in the higher amounts. But here, most importantly, by using this scatter plot, we can see there is a rough relationship between total bill and tip. As the total bill goes up, the amount of tip goes up as well. Now let's say for the same graph, data is equal to tips, which is our data frame. Then on x-axis we want total underscore bill, and on the y we want tip. Now there's another parameter here. Called kind, which is by default given as scatter. So for this kind parameter, we have these different options given here. Let's by default we have scatter here. Let's check out the other options as well. So let's check this hex bin first. So what this hex does is it divides the entire plot into many different hexagonal bins, and then based on the number of points inside the bin, it gives it either a darker color or a lighter color. The more number of points inside a bin, the darker will be this hex bin. So we can look at the distribution of the data here. Similarly, if you can use reg, which is short for regression. So this regression will again plot scatter plots, but will also draw a regression line through the points. This regression line shows us the rough probability of tip being in the particular range for a particular amount of total bill. This is also used for predictions. Let's say if the next customer is likely to have a bill of $50, his tip is likely to be in this range of $5 to $6. However, that may not always be the case, as you can see from this data points. Another one is KDE, which will draw some curves like this. And if you check here, we have some other parameters again. We have height, which is for height of this figure, ratio, which is basically the ratio of height to width. So you can adjust these things if you want. So here we saw how to analyze univariate data using histograms, and then we saw how to analyze bivariate data, that is two variables, using a joint plot. Now we have another plot called pairplot. A pairplot plots a pairwise relationships across an entire data frame for the numerical columns, and supports a colored hue argument as well for categorical columns, as we have seen earlier for the histogram. So what this will do is it will plot pairwise data for all pairs of numerical columns in a data frame. So let's see this. We just need to pass in our data frame here, and it will automatically plot this for all pairs of numerical column. Now depending on the size of the data frame, this could take a while if we have a very large data set with a lot of data. For now, let me zoom out a little bit so we can see this better. So here we had only three numerical columns, which were total bill, tip, and size of the party. So on the x-axis we have all those three, and on the y-axis we have all three numerical columns. So total bill versus total bill is just a histogram, as it is a univariate data. Then total bill against tip is a scatter plot, And total bill, again size, is a scatter plot as well. Here this data was discrete, it wasn't continuous, it was just integers 1 2 3 4 5 6, and so it has plotted the bill for each of those size here. So the benefit of using pair plot is we don't have to analyze each numerical column or a pair of numerical columns separately. We can just plot a pair plot for a given data frame and see the univariate distributions of all of those numerical columns, and then we have the comparison of each column versus other numerical columns. So if you want to read this same scatter plot the other way around, if you want the total bill on the x-axis and tip on the y-axis, you can look at this. Then this is tip versus tip, so a histogram for that column. Similarly, we have a histogram for size as well. Now here, if you check the doc string, we have a hue parameter again, and then we have a palette. Palette is for colors, color combination. And then once again we have this height and aspect ratio. Aspect is just the ratio of height versus width. So you can use those parameters as well if you want to change the size of the entire diagram. So for you, let's go with this sex column, which is categorical data for male and female, and it will separate out the data for each of these plots based on this category. And you see we have this blue color for male and orange for females. We have a palette. You can use the palette parameter here, and if you want to use a different color combination, one of those color combination is cool warm, and we have this in lighter color. It's the same blue and orange color for cool warm. You can use magma as well. This is slightly different color combination here. Then let's check summer, which is more on the greenish side, and we have many different palette options available. You can google for color combinations for Seaborn. It will give you official documentation for the Seaborn, and you can check all of the palette options available there. Next we have rugplot. A rugplot simply puts a dash mark for every data point on a univariate distribution. So for one column, let's say for the total bill, for each of the data, it will put a dash mark on the x-axis. So let's quickly check this out. We have this rugplot, and let's say for tips, we will pass in this total underscore bill. So let's pass in this and see for each of this total bill, each data point, it will put a dash mark there. So these are basically building blocks of a KD. You won't be using rugplot just by on your own, but it's good to know how to plot it. Now let's move on to the KDE plots. The KDE plot replaces every single observation on this rugplot with a Gaussian normal distribution curve centered around that mark. So for each of these dash marks, it will create a normal distribution curve and then adds up the y values for all of the x values on the plot. So now, as you can see on this diagram, here for the same data set, we have two different figures here. On the left one, we have a histogram, and on the right one, we have kernel density estimate, which is constructed using the same data. So here, if you look at this bin, there are two data points inside this bin. So this bin is higher than the other bins, all of which has a single data point. Now for KDE plot, for each of these data points, imagine this red curves which are normal distribution built around each of the data points. So the peak of this red curve would be at this data point, and then it will taper off on both directions. Now for KDE estimate, all of the values of y at a particular x values will be added up, and this will give us a smooth blue curve which will be the kernel density estimation. So basically, what is the density of that particular kernel on the x-axis? It will give us an estimation. So on each of these data points, a normal distribution curve is built with the mean of that data and standard deviation of 1.5, and then for each value at the x-axis, the corresponding y-axis for each of these normal distribution curves is added up and is plotted using this blue curve here. So to plot this, we can use sns.kde plot, pass in your data, which is tips, and then on x we can use total underscore bill, and it will give us a KDE plot. Now here we can also plot the KDE plot equal to tips and x is total underscore bill. So here we can plot both KDE and rugplot together as well. So here we can plot both KDE and rugplot together as well, and you will get this plot. This is useful for analysis of univariate data if you want to know the rough estimate of where a particular data could lie. However, if you want the exact distribution of the data, you should use histogram. Next, we will move on to the categorical plots.